Alright, for the last lesson of Unit 1, we're going to be talking about domain and range and doing an introduction to those. So, for domain, that is how far a function extends to the left and to the right. So, we're going to explain using x values how far the function goes left and right. And then as far as the range, that has to do with how far a function goes up and down. And then we can use y values to explain that. So domain has to do with left and right, range has to do with up and down. So looking at these two graphs, we'll actually look at the top one first. So just looking at the top problem, and we have a function that looks about like this. So it's a straight line and it continues on forever, and the way we know that is because it has an arrow on the left and the right side. And so it's a straight line and it's continuous, which means that it's a linear function. So that's the family of functions that it is a part of. Straight line and continuous, we know it's linear. The parent function for a linear function is the function y equals x, which is very simple for a function. If we have our coordinate plane and we know that y equals x, say that x equals 0, well, y would equal 0 and we'd get a point there. If x equaled 2, then y would equal 2 and we get a point there, and so on with 3 and 3, there would be a point there. If we went to the left, we say we went to -1, then there would be another point at -1 on the y, and there would be a point there. So if I connected those, it would make this straight continuous line that goes on forever. And that's what these arrows are symbols for. So that would be the parent function of a linear, the parent linear function. Now let's go on, and we're going to talk about the domain and the range. And so domain has to do with how far it goes left and right, and we're going to use x to explain that. So if we take a look at our function over here, we have an arrow on each side of it showing us that it would go off the screen that way and off the screen that way and extend forever, as far as you can picture, and then some. So if we're talking about the domain, that's how far could I go to the right and still find a point? Well, I could go down and find a point right there. I could go to the left as far as I want and still find a point. So for the domain of that, we're going to say that the domain is all real numbers, and the way that we write that is with a fancy R like that. So that's all reals. Maybe just make a note at the top that that means all real numbers. Alright, so then the range, we're talking about how far it goes up and down, and we're going to use y to talk about that. So along the y-axis, which is there, how far up and down does it go? And just the same, if we go down to say -3, we could come over and find a point. If we went to -5, there'd be a point there, and so on forever. And then if we went up to +5, we could go left and find a point. If we went up to +50, there would still be a point over there to the left. So once again, y is going to be all real numbers. Alright, so moving on to the bottom problem, we have a little bit different kind of function where it's sort of this U shape. And once again, it has those arrows on top, meaning that on the left side it extends left and up forever, and on the right side it goes right and up forever. So we saw this last video where we had a function that was shaped like a U. That sort of function is called a quadratic function. So quadratic functions are either shaped like the one in the graph, or they can be upside down. They can also be wide, like this, or skinny like this. Those would all be examples of quadratic functions. And the parent quadratic function, so the parent linear function was y equals x, the parent quadratic function is y equals x squared. So whenever you see x squared, it's probably a quadratic function. Alright, just to state the domain of the function and the range, domain has to do with left and right, so x equals, and we have an arrow that points that it's going to extend forever to the left, and we have one that shows that it's going to extend forever to the right. Even if we went all the way out here, we'd still be able to go up and find a point. So it extends left and right forever, so it's going to be all real numbers, and that answer for that. Now if we look at the y, we're looking to see how far up and down we can still find values. So if I went up to positive 3 right there, I could find a value to the right and to the left. So that's a valid point. If we went up to 5, there would still be one. Even if we went up to 8, I'd be able to go and find a value right there. Continuing on to about 20, I'd be able to find a value here. So we could go up forever and still find a value, because that's going to continue on that way. Now if we go down from 3, if we go to 1, there's a value on the left and the right. And then if we go down to negative 2, there's still a point there. But if we continue on to 3, there aren't any points to the left or to the right. And same thing if we go to negative 4 and negative 5. So the lowest possible place we could go is negative 2. And the way we're going to say that is we're starting at negative 2 and going up. So we can use an inequality to describe that, where y is greater than or equal to negative 2. Because y can be negative 2, it can be negative 1, it can be 0, 1, 2, and so on, but it can't be anything lower. So that's what this is telling us, that it can't be anything lower than negative 2.